To start off with, this isn't going to be another comparison app. We don't need any more of those. This isn't going to be the next Google Maps. What this is going to be is a bespoke standalone device agnostic of iPhones and Androids. It's going to show the nearest petrol station that has the cheapest fuel for my fuel type, and it's going to show the distance to that particular fuel station. It's not going to require any input from the rider, and it's not going to require any subscription from an external provider. But I know what you're thinking, it all hinges on data. Where the hell do we get these fuel stations and fuel prices from? So let me introduce you to this government-provided API. An API in this context is a special website URL that you would normally type into your browser for me to get up-to-date fuel stations and fuel prices. They update their data source twice a day, so I'm going to have to repeat the steps of data ingestion multiple times. So I'm going to need some reusable, reliable code that can run even whilst I'm riding my motorbike. So we found the data. How do we make it motorbike ready? There you go. There's the solution. That is a lot to ingest. Let's break it down. We've got the government's fuel station data endpoint, their API. We need to write some cloud code to get that data and store it. We need to store it in an easily searchable way using our location, so it makes sense to use geohashing. What is geohashing, I hear you cry? It uses latitude and longitude coordinates. Latitude is how far north or south you are from the equator. Longitude is how far east or west you are from the prime meridian. The prime meridian? That's London. So I've got my coordinates, and each petrol station has their own coordinates. But if there's thousands of them, how do I really work out which one's closest? Well, I could write some really complex maths and have a guess, or I could just stick a grid over the United Kingdom like this. And how about I give a unique word to each square in that grid? Well, that's very similar to the unique algorithm, what 3 words? But that's proprietary and hidden, and there's no relationship between the words. What we need is a predictable set of rules for us to know which squares surround us on the grid. So the answer is geohashing. I've put a very simple example on the screen. The center geohash is us, based on our longitude and latitude. Based on a very simple set of rules, I can predict which squares are north, south, east, and west of us. The price data is simpler. So we've got a price data API from the government. I've got to write some cloud code to get that price data and store it, but just store it in a sortable way so I can get cheapest first. Moving on to the juicy bit, I'm creating my own API. My motorcycle from that device I mentioned earlier will be sending GPS data to an orchestrator that will forward that request on to some cloud code that I've written that will calculate my position using my longitude and latitude to a geohash. It will then use that information to get 8 other geohashes around me to get the nearest fuel stations, cheapest prices of fuel based on the fuel type I provide, and make sure the response to my motorcycle device is cheapest first. And finally, we've got the hardware, a physical GPS module where I can get the latitude and longitude of my position every so often. We've got an ESP32 that allows me to orchestrate all of this with magic, or I suppose code. I'm hotspotting to my phone to be able to make these API calls to my API. And then I've got an LCD screen to show these results and make them look pretty. It's certainly time to bring these ideas to life. We've got the 3 cloud functions I mentioned, some cloud secrets, basically these are API passwords. 3 databases exist, one for the passwords, one for the fuel prices, one for the fuel stations. Let's see what our fuel station cloud code does. You're looking at the results of me manually poking my cloud code. What a mouthful. This has allowed me to call the government API 18 times, as they would only send a certain amount of data per request. After the 18th time, they've said, we haven't got any more. You've got everything we've got currently stored. And here is my copy of that data in my database. I'm going to click into some records and show you what we've got. You're going to see things like the geohash I calculated when I inserted this record based on the fuel station's longitude and latitude. And you're going to be able to see other information like the fuel station name, the original location, including address lines and longitude and latitude, and its opening times as well. And really, it's a similar story with the fuel prices. I've just poked my cloud code to download the latest fuel prices. You can imagine that you would download the fuel prices more often than the fuel stations. The chances are the fuel station details probably aren't going to change more than once a day. Very similar story with the database. Here's a random petrol station. Here's the fuel that it surfaces and their prices. Click into another one. You're going to see some more fuel details. Again, it's only displaying the prices of the fuel that that station actually sells. And finally, the meaty bit, my API to get the cheapest fuel. I'm now playing the role of motorcycle. I am near the London Eye. Here's my longitude and latitude. I am sending my longitude and latitude and fuel type of B7 standard to my API. My API calculates and responds and says Asda is the cheapest for B7 standard with the price 177.7, I believe. And then it's given me other fuel stations that are further away and more expensive. Similar story, I'm now near the Edinburgh Zoo, copying my longitude and latitude, and I'm now searching for the fuel type E5. So I'm going to make my API request and find the nearest petrol station with E5 fuel, the cheapest E5 fuel. So it looks like it's that Tesco. I'm not going to pronounce that. It looks like the price is 164.9 and it's 1.05 miles away from me. You can see it's returned other fuel stations that are further away and more expensive based on the fuel type E5. We've magically travelled to Silverstone Circuit and I'm copying my longitude and latitude and I want E10 fuel. I'm going to make that request to my API, pretending I'm a motorcycle, my motorcycle device. It's returned that fuel station with the price of 156.9. Based on my geohash location, another geohash is near me. That is the cheapest, closest petrol station for E10 fuel based on my geohashing conditions. Building the bit that's going to go on the motorbike. So it's nice that it's color coded. On the left is the GPS device, the white thing. In the middle is the ESP32 and the red thing is the LCD screen. Here's what the code looks like. To cut a long story short, it loops over that every 15 seconds to get the GPS coordinates, to make that API request, to display the results on that LCD screen. And for comedic value, because I'm terrible at soldering, I haven't. So here it is in a sandwich box, very brittle, ready for travel. My partner tethered this to her phone and took it out on the open road. She took several pictures along the way, showing fuel stations getting closer, different fuel stations showing, all based on E10 fuel. I defaulted this device to E10 fuel for testing. And while she was testing it, she found an actual unscripted bug. She said when she was sitting on the actual petrol station forecourt, the petrol station itself wasn't displaying on the device. What I realized I'd done was search for all the petrol stations around my location, the middle one, but not search for my location itself. So if my geohash matches the petrol station's geohash, it wouldn't return the petrol station at all. So I updated my code to use my geohash alongside the other 8 geohashes I use to find the nearest petrol stations to me. And then, as a courtesy, I took it out on my motorbike. You're going to see that I've learnt the biggest lesson when making this video. You can never have enough footage. I wish I had more clips to show you. Here's me eagerly pulling up to my first petrol station. Here's the distance and fuel price showing for E10 fuel, Shell. The price is 163.9. Very nice. Driving to the next petrol station. Weirdly enough, it's literally around the corner. And there she is, 162.9 Morrison's. Let's zoom in. 162.9. Here we've pulled over away from a petrol station. Let's have a look and see what it says. Turns out I haven't actually travelled that far. It's showing the same petrol station, but 2 miles away. 2.1 and 2 miles away. So, to summarise, we built an independent device that uses up-to-date data from a government API, well, 2 of them, to find the nearest, cheapest fuel based on our fuel type. And if we had the skills to solder it up, it wouldn't be living in a sandwich box in my top box. We could mount it to the handlebars. I priced everything up. It came to just under £25 from AliExpress, all the hardware bits. And the cloud compute cost was nothing from AWS. For anyone interested, hit any of those URLs, have a look at the code. In the README, it also describes how to set this up for yourself. Thank you for watching. Please like, follow, alert, whatever else YouTube wants you to do. That would be great. Now, I just need to find something else to build.
Code and corners, code and corners, code and corners.